So we talked about the big two, the most important, um, or the most covered, the most popular sampling methods that are actually good. So we talked about in regards to our first two randomly sampling methods. And I'm going to try to give also some pros and cons to them as well. So our first one was a simple random sample. All right. And a simple random sample was when we have a random sample of everyone in the population of interest. All equal chance of selection. Pros. It's random. All right. First pro, of course, it's random. That's the most important thing. So it's a random sample. Simple random sample is random. The second one, it is quite easy to select sample. So it's basically easy because if you know who's your population, it's easy to select who's going to be in the sample. Cons. The first con that's in here is that this suffers from this has a high variability. Okay, so that's the first con. There's high variability. Now, we recall this variability that I'm referring to here, and we'll have another one. We also refer to this as sampling error. Now, sampling error is not bad. And so what I mean by this part right in here is that I mean that results from sample to sample can be high. So on average, it's going to give you, and I forgot one of the other pros. This suffers, so when I say random, because it's random, it doesn't suffer from bias. And because it doesn't suffer from it, there's not bias. That means on average, I'm going to get a pretty accurate representation of my population. So when something is random, the reason why we randomize is to eliminate bias. So the purpose of randomization is to eliminate bias. However, we should know that bias and sampling error are two different things. So no bias, that's good. However, high sampling error. Results from sample to sample can be, I said high, I should have probably used a better vocabulary word there, drastically different. The other con is that in practice, individuals within sample can be very spread out, causing time issues in collection. So for example, if you were doing a simple random sample of students in Boston Public Schools, all right, the students within the schools can be located everywhere, and you might have students that are located all throughout the city. some even outside the city. So what would happen here is that maybe you select 10 students, and it could turn out that these 10 students are located all over Boston, which can take forever to do. So if you're only taking a sample of, and if it was 100, that becomes very different, because within every school, you're going to have to go to their homeroom or meet with them. It's very hard to meet with any individual along with another individual, so you can suffer from really, really big time issues. Now, this is mostly a con in the practice of doing it, which is why some of the other methods that I'm going to get into are actually turns into pros, or why we use them. Simple random sample is good. However, the best one to typically use is a stratified sample. This is where homogeneous groups, also known as strata, are identified in relationship to response variable and random samples taken from each strata. Okay, so the con here kind of breaks it down. So now this one is the best one, all right? This one suffers from the least amount of bias, and it suffers from the lowest variability. It has the lowest sampling error. So in terms of pros, it is random, which of course means non-bias, and it has the lowest, so I'll say lowest or low variability. Lowest, I'll put lowest variability. Lowest sampling error. Now, I do want to point out, sampling error exists always. There's always sampling error. All sampling error means is variability. That if one student took a sample and another student took a sample and they both took the sample the same method, stratified, you're not going to get the identical results, because who is included in your sample is random. So you're going to have a different mixture of people within your sample. Now, how drastic of results should we expect? Well, if it's a simple random sample, most likely we're going to have drastic differences. In a stratified sample, we could still have drastic differences in responses, but if done correctly, it'll be less than a simple random sample. Cons. All right, the biggest con comes into here is that it is very difficult to correctly identify strata. Now, in other words, it can be when I say difficult, it could also be time consuming. Okay, it can be very time consuming. It can be very just difficult to actually figure it out, to correctly identify strata. When I say, once again, in regards to response variable, a lot of people will say, oh, well, like I mentioned this in the last class, I'm going to stratify on gender. And everybody just picks gender. And they're like, I say stratify on a variable. Explain, and everybody will be like, oh, well, in a simple random sample, I just ask everybody in the class. But in a stratified random sample, I'm going to take a random sample of just the males and then a random sample of just the females. and they think that's stratified. Technically, it is a stratified sample. However, it does not meet my goal. It's gonna be more time consuming, and it turns out that if you did that, it could potentially give you no better method than have just done a simple random sample. The thing here is that that variable, the variable to stratify must have relationship to response. That's what I'm trying to say. So if we were talking about eye color, as I mentioned, gender probably has nothing to do. So if you were to take all the time and effort to identify all the males from all the females, and then take a random sample of just the males, and then just take a random sample of just the females, your results are no likely to be any better than a simple random sample because gender doesn't have anything to do with eye color. Now, what does? Well, most likely there are connections that are found, for example, with eye color for ethnicity or race. That could be something, you know. There are drastic differences. Some people of one race have drastically different eye color variations than others, and that could be true, and that is kind of true if you're an expert or you find the research on that. Now, how would you know that? That's what comes with the difficulty. Now, on an AP exam question, like I said, they will specifically tell you inside the problem what the stratified is. And so what you need to do is not only do you select that, but then you have to state why, and they'll say why. So why did you choose that? You don't go, because that's what the AP exam question says. That's what they gave me. They gave me gender. And you have to say that, gender, there is a relationship between gender and height. Males, the distribution of male heights is different than the distribution of female heights. All right, you can talk about those, and a lot, and something like that, we expect you to be kind of an expert in. All right, when we talk about things like grade level, why do we select different grade levels? When we talk about when school should end, we talked about the idea about students working. Now, there's many answers that are correct in terms of why. We just need to have you state a reason, and we might go, well, that was pretty far-fetched, but they understand the concept of and it might not even be true, but we know what your concept is. If you were somehow to believe, and you were say something like, I stratified on gender for eye color because I think males are more likely to have blue eyes than females, and we'll probably look at that and be like, oh, that's pretty far-fetched for somebody to think that, but maybe somebody grew up with an education system that is true. So if we understand that you understand the concept of why you're stratifying, because you believe that variable has a significant difference on the response variable, then we'll accept it. However, if in the question gender is not mentioned, you better be picking something that's from the question that is stating. Don't try to magically come up with something that's far outside there. You are specifically being asked about that problem. So if that problem says things about grade level, then you better talk about grade level. If it talked about the cities in which they live, then you want to talk about stratifying on cities. A lot of people will try to do all this work, and they, like I said, the biggest con here is that sometimes it's difficult and sometimes it's impossible. Sometimes you have no expertise in the subject matter, and therefore you can't figure out what you would stratify on. Will gender matter? I don't know. Will somebody's age group matter? I don't know. And if you don't know, you can't stratify. All right? Questions on simple random sampling and stratify. These are the most important two, but not the only two. Okay. The next random sampling method is called a cluster sample. And I want you to note that a cluster sample is random. Okay, it's a random cluster sample, cluster random sample. But we just refer, just like stratified, we usually don't say the word random within it, but a cluster sample is. A lot of people mistake cluster samples with stratified samples. Okay, so a cluster sample is when heterogeneous groups are identified in the population. And what I mean by this is that you can think of this as small, mini representative subpopulations. So, let's say we do feel like gender is something that is we should stratify. For example, there is a relationship between gender and whatever it is, or we don't even know. We don't even know what the variables. The idea behind when I say this idea behind heterogeneous is that if you identify groups, for example, homerooms, CASs, okay, for the most part, at least in ninth grade, because especially in ninth grade, the advisories are very heterogeneous. All right, we'll focus on the ninth grade one because in ninth grade you don't get to choose, right? They're just ninth grade. So in other words, if I was trying to find a sample about ninth graders and what are ninth grade students interested in, then the CASs, each of the ninth grade advisories, would be very heterogeneous groups. They were a pretty good mixture of all ninth graders. So you can think that it is reasonable to believe that each of the advisories in ninth grade is a good representation of what the population looks like. You know, they weren't specifically created in that regards. That could be in regards to any variable, any question. The same might not be true for 10th through 12th grade advisories when you get to choose if we're talking about, but once again, it would depend on what you're doing. For the most part, I would think that actually they still are heterogeneous, although we have some specific that are, for college applications, for things like knitting or volunteering. There are possibilities that the response variable that you're collecting could make it such that these advisories are not heterogeneous, but for the most part, we can think of they are. When it comes to the AP exam, basically we take what the information of the stem of the question tells us. So if the stem of the question doesn't tell us any differently, then we can assume that each of the populations is a strong mixture. There's no particular breaking up of why this group is different than this group. If the groups are just males and just females, those are like, well, on the variable of gender, these two groups are homogeneous. They're all males and they're all females. But if this group is a mixture of males and females and this other group is a mixture of males and females, now we refer to that as a heterogeneous group. All right. Now, this is where also it gets very different. Each clusters. So the heterogeneous groups are referred to as clusters versus stratified. Each cluster is Each cluster is labeled, is given a number. And written down on equal sized pieces of paper. This is kind of what I referred to as the previous one as well, and how to do it. Placed into a hat mixed well and then in groups selected. Everyone in the selected clusters is sampled. Now, what I'm trying to say here, now, this sounds like a simple random sample. But in a simple random sample, each individual was numbered. All right? So you are selecting groups, not individuals. So in a cluster sample, for example, in a cluster sample, if it was a simple random sample, all right, and a simple random sample, I would just number everybody in the entire school. And let's talk about CASs, okay? We're focusing on this idea of CASs. In a simple random sample, I would just number everybody in the entire school, write them under everybody's names or number them, give them a number, you know, your ID numbers, whatever it is. Write it on an equal size piece of paper, put in a large hat, mix it well, and select. Just select it from the entire school. That's a simple random sample. Stratified sample. In a stratified example, what I might do is I might, for CASs, I might go to every single CAS and randomly select, let's say, 2 students. So from every single CAS, I will select 2 students from every strata, because I might think that each CAS is different. So in a stratified sample, I would select 2 from each. If you ever see something, you'll see this on your homework tonight, it says you're going to select 5 from each blah, 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 blah. That's stratified. Cluster. I'm randomly going to select 5 of the CASs. Or I'm going to randomly select 2 CAS, 2 advisories. So I randomly select, so I number all the advisories, and I randomly select 2 of the advisories. And whichever 2 advisories are chosen, I'm going to sample everybody within there. So everybody in the selected cluster advisory gets sampled once they are selected. So if you are an advisory with somebody else and that advisory is chosen, you all get sampled. You were in that sample cluster. It's not selecting individuals. Pros. It's random. And in practice, can limit time consumption. Think about if you're doing this around the school, around the city of Boston. Instead of selecting students from all across the city, as would be done in a simple random sample or a stratified sample, in the end, you end up only sampling small neighborhoods. Okay, I'm going to sample the students within this small neighborhood or this street. All right, so now you don't have to go very far. When you get to a location, you're able to sample a lot of different individuals once you get there. So once you go to the advisory, you're like, all right, everybody in this advisory, everybody here is in my sample. So I'm going to give directions to everybody. We're going to collect it all together right now. Whereas in a simple random sample, you'd have to do this to each individual separately sometimes, pretty much. In a stratified sample, you'd have to do it for every single strata, every single advisory. And so in a cluster, you only have to do it to the entire group, and then whatever entire other groups were chosen as well. Cons, once again, this could suffer from high variability, sampling error. It could suffer from very high variability, actually, in some cases. If not heterogeneous. So if the groups turn out to be not good mixtures, and it turns out that the groups are actually very much homogeneous with whatever the response variable is, that could cause a lot of trouble. So that's cluster sample. Next one. The next sampling method is called systematic random, sample. Okay. A systematic sample is where a random initial individual is selected, start, random start, we call this, and then every nth individual after is selected. So, or sorry, I want to say not nth, I want to say ith. So it has to be random, right? It's still a random sample. So we call this random start. When you start, who is the first person to be selected in the sample? That must be random, all right? So the first person who is selected must be random. So you ask you randomly select, or you select the fifth person is the fifth person that walks into my classroom. Or for example, talking about Zoom here, I could have said the third person, and I would have randomly selected this number beforehand. The third person to enter the Zoom session will be my first student in my sample. And then every fourth person that signs in after that is going to be in my sample. So I'm going to sample the third person, the seventh person, the 11th person, and the 15th person. That gives me a total of 4 people to be in my sample. All right. There was a random start. Now, pros is that it says random. So therefore it's not biased. It could be not biased. However, and I said pros, cons, and it may, over here, may suffer from bias. So I want to point out that if you do a cluster sample and you don't do it the right way, it becomes bias. So just because it's random does not mean it's bias. So pros, random. However, cons, you may suffer from bias. So the big con here is that order must not be related to response. So, for example, we talked about this thing about you logging into the Zoom, right? Let's say I was collecting data on how much you enjoy this class. Okay, and that's the data that's collected. Something around the idea of of how well you're doing in AP Stats, how much you enjoy AP Stats, something along those lines. I mean, we're going to measure this on a graded scale, something like that. Can somebody verbally tell me, because I know I've been having to do a lot of talking today, a lot of just vocabulary, and I've tried to break this up over 2 days for you, right? Can somebody tell me what the problem is about the order at which people log into the Zoom session and how much they enjoy the class? What's the problem there? Is there a relationship? And if so, what is the relationship? The order at which you log into the Zoom class and how much you like the course. Is there a relationship? And if there is, what is it? Can I get somebody please to take an attempt to try to talk about that? What is the problem there? So we got somewhat of a response. It's because there is a relationship. Basically, in this example that I said, so for example, so I did get a response. In example, student order logging into Zoom and how much they enjoy course. There is a relationship here. The relationship exists. All right, and that's what I told you. Those who log in earlier are more likely, doesn't mean they are, more likely to enjoy the course more. Doesn't mean that because you log in late or that you don't like the class, or just because you logged in early doesn't mean that you like the class a lot. But more likely, we can see that there is, and it is very easy to explain, there is a relationship. People who are logging into the class are more likely wanting to or to have a bigger enjoyment. So you'll get a question later on, for example, about cafeteria food. And so is there, if you were to randomly sample, once again, a systematic sample, could there be a problem? Is there bias? And the answer there is yes. A systematic sample for how fast someone comes and gets their food can be problematic, because people who get to class earlier, get to the cafeteria and get their food earlier, more likely will enjoy the food. So now, I mean, it took us over 5 minutes to get responses. I'm going to cover the rest of the material. I'm not covering any less material. That was pretty much 5 minutes wasted of me being able to take more responses from you. I'm just going to have to go through the material. The fifth method is a multi-stage. Or actually, yeah, I'll go multi-stage. Sample. And basically a multi-stage sample is when two or more sample methods used. The most common method, the most common one is a randomly select a group, and within each group randomly select individuals. So it's like cluster and stratified. It's like a combination of cluster and stratified. So This one is the most common in practice. I could have also done systematic. I could have said I'm going to randomly select groups, and then within each group, I'm going to go to that advisory. I'm going to get to the advisory early, and then I'm going to do a systematic sample. That could have been one as well. So the third person who comes in, they're in my sample. Every fourth person thereafter is in my sample. I could do that for every room that was randomly selected. That is multi-stage, where I'm doing two of the methods. I'm selecting groups. Almost always they start with selecting a group. And then once you get to that group, then you do it. All right, so you have groups, and then when you get to the group, you do another random sample. So typically there's two randomizations that happen, random and random. That's called multi-stage. Not too commonly covered on the exam. Non-random sampling methods. These all suffer from bias. There's no ifs, ands, or buts. These ones suffer from some sort of bias. Now, it should be noted that in the above examples, when I talked about cluster and systematic, they could have suffered from bias if not done properly or in the right ways. These ones always do. Number 6 is the most common one, and you'll see this inside your homework for sure. This is called a voluntary response bias. This is one of the worst samples that's actually used, and it is terrible because voluntary response sample, sorry. I have to rush now. That 5 minutes back. This is where individuals self-select themselves, or self-select, I guess that's redundant, into the sample. i.e. respond to website, newspaper, so in a voluntary response, or I want to say a meeting, when the individuals are not randomly selected, and it says, well, anybody who shows up, anybody who responds is my sample. All right, I'm going to give this sample out to everybody. I'm offering this to everybody. Anybody can, please, anybody respond. If my sample only includes those, if my sample includes those who choose to be in the sample, so you could choose to be in or be out, this is very problematic. This suffers from voluntary, and it has its own bias, voluntary response bias. And voluntary response bias is where those with extreme views more likely to respond. So for example, if the question was about, going back to in-person learning, and we hold a Zoom meeting, all right? And whoever attends that Zoom session is my sample, and I'm going to use that. So of the people who attended the meeting, people are very much against returning, all right? But everybody is either really against returning or really pro-returning. So those who show up to the meeting are going to have the extreme responses. You're going to have those who are very, very, very much no, 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 and others that are very much yes, 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 yes. No, there's still a pandemic, a health crisis, we can't do this. And then you get the very other extreme, yes, we're doing all the students a disservice, the students don't have internet, and these are the two extreme points of view. But in reality, the population has far more gradient responses. They're not as far leaning to one or the other. Might be right in the middle or might lean slightly over. But because they're the only ones that respond, you're only getting those with the extreme views, and then therefore you don't know your true population, your true response for the population on average is somewhere in the middle, but you don't know where, because these are the two extremes. You should never have confidence in results of volunteer samples. So if that occurs and it says, question says something like, how much should you take, how strongly would you take this? Should you take it with a grain of salt? No, not even with a grain of salt, because it's a voluntary response bias. 7, convenience sample. This one is the worst. Convenience sample is the worst of the worst. This is the lazy, fast, quick sample that suffers from undercoverage. There will be many groups of opinions left out of the population of sample. This is that Truman, Dewey wins. If you only contact everybody by phone, you're going to miss all of those people who don't. And that's a convenient sample in that sense. Well, in that case, that suffered from undercoverage. Convenient samples always suffer from undercoverage because of the fact that you most likely just asked your friends. And I know we're right at the end with 1 minute. The last one is called, and we don't really refer to this much in AP Stats, but I'm going to call it anyways, judgment sample. A judgment sample is where an expert attempts to pick a representative non-random sample. This is always bad. Humans always have bias, even if you don't think that you do. So a lot of times people say, well, I'm going to select one of these and 2 of those, and you can't. You don't know. It has to be random. You need to put in that random, because nobody's a true expert in that field. I mean, it could be, but you have to be like an expert. Like I said, judgment sample is not really on the AP exam, but it is our 8th type of sample that we need to cover. I need to get some more responses coming out of you. We should have had a little bit more time for me to do at least a couple of examples. Your homework is posted on Google Classroom. I'm over time now. That's all I have. I'll see you tomorrow.